Welcome everyone. My name is Gábor Kisvámosi and I'm the leader of LVGL and also the CEO of LVGL LLC. In my presentation, I will talk about how you can use great user interfaces with LVGL on the new ESP32P4. I will start with introducing LVGL in general. After that, I will tell you how you can use or add LVGL into the ESP32 ecosystem. After that, we will check out some use cases about some great LVGL features that you can utilize with ESP32P4. Finally, I will talk about our future plans, and of course, I will be happy to answer your questions too. So let's start with what LVGL is. LVGL stands for Light and Versatile Graphics Library. So it's a graphics library which helps you to create impressive user interfaces even for resource-constrained embedded devices. It's a full-featured library. It contains more than 30 built-in widgets like keyboards, charts, sliders, buttons, labels, text areas, and many more. What you see on an Android or iOS application usually can be realized with LVGL as well. LVGL comes with a powerful style and layout system too. These are inspired by CSS, the styling scheme of the web pages. So the same technologies which make the web so powerful are available on LVGL as well. It includes more than 100 style properties and modern layouts to automatically and easily arrange the size and the position of the widgets. It also comes with an advanced typography system supporting many languages, including the Asian languages, the Arabic languages with right to left, and left to right writing direction support, and of course the Latin-like languages too. We will check out some examples for these later in the presentation. LVGL is free and open source. The whole source code is distributed under an MIT license and fully available on GitHub. In the practice, the MIT license means that you can just download LVGL, add it to your project, and use it without any issues, even for commercial projects. The only thing that you need to do is adding a note in your documentation, user guide, or README to tell people that you have used LVGL in your project, and that's it. I'm very proud to say that LVGL is the most popular free and open source graphics library at this moment. It's downloaded every minute from GitHub, and it's already supported by the leading vendors of this industry. Of course, it's being supported by Espressif as well. LVGL is a platform-independent solution. You can use it for any microcontroller, microprocessor, any real-time or normal operating system, and you can drive any kind of displays with it. It includes OLED, e-paper, grayscale, TFT displays, or even monitors. And finally, I'd like to tell that we are doing some services. We are doing UI design, UI implementation, and you can consult us if you have any questions during the UI development. We also have a broad global partner network. So if we don't have capacity to take your project right now, I'm sure that we can find a great company for you who can help. On this slide, you can see some interesting stats about LVGL. The first thing that you can see here is how many contributors we already have. It's more than 400. It means that more than 400 people helped to make LVGL better by fixing issues, reporting bugs, or implementing smaller or larger features. We also have more than 15,000 stars and more than 3,000 forks. As I already mentioned, according to the statistics on GitHub, we can see that LVGL is being downloaded in every minute. However, it doesn't count other sources like Platform.io or Arduino libraries, or even ESP registry. If I consider all these sources, it's quite reasonable to say that someone downloads LVGL in every 10 seconds, which is, mind-blowing for me, to be honest. I'd like to also show you our new website. It was published in July, and basically all I have said so far in the presentation is available here as well. On the homepage, you can see some basic UIs and related code. So you can see how you can create an arc, for example, set the size, the position, or create a label on it. All these basic examples are available right here. Here you can see our partners. These are some more complex demos. The supported frameworks. But the other page that I like to show you is the features page, because here I can showcase some great LVGL features. This is our basic widget demo, where you can just try out how the basic widgets look like. All these demos are written in C, but they are compiled to an HTML page, so that HTML page can be shown on any websites. On some projects that we are working on, we usually compile the actual UIs to web pages, so the designer team or the managers can easily take a look and share their comments. Here you can see some rendering features. On this UI, there are no images at all, or these are rendered by LVGL, including these gradients, these shadows, these arcs, and all these shapes here. This is about the styles. This is a basic LVGL slider, and it shows you in how many ways you can change its appearance. All these are rendered by LVGL's rendering engine, and only a few images are used for these stripes or this knob, but all the other stuff are created and adjusted by just changing some style properties. This one is about the layouts. Here you can try out LVGL's flex layout in action. As you can see, these boxes are just placed next to each other. However, if you enable the row wrap mode, these are wrapped automatically. You can also arrange these into a column. And yeah, you can play with it if you like. This is the demo that you have already seen. Here we like to showcase the multi-language support of LVGL and how you can mix various fonts. Here we have a Chinese text, an Arabic text, an Indian text with some inline emojis. This is about transformations. In the latest version of LVGL, you can you can apply any transformations on the widgets. It doesn't have to be an image. It's really a working widget, not just a simple image. LVGL takes a snapshot in this case and applies a transformation as it were an image. But all these are working in runtime. Here the scrolling features. I don't want to go into the details, but as you can see, there are some very nice chained scrolling, this elastic scrolling feature, and many more that you can try out by adjusting these switches here. And that's it. Let's get back to the presentation. So let's see how we can use LVGL with the ESP32 ecosystem and how can we get started. I think the best source of LVGL in order to add it to the ESP IDF for the ESP projects is the ESP registry. LVGL is distributed there as well. Here I sorted the components by total downloads, and you can see that LVGL is the third. So it's the third most downloaded repository in ESP registry and the first source-party library. So if you would like to add LVGL to your ESP project, you can use the usual IDF commands to do so. If you are using Arduino or Platform.io, you can also add LVGL very easily because it's being distributed as an Arduino library and a Platform.io library as well. Besides that, we are maintaining an Espressif-related documentation in LVGL's documentation where we list all the related commands, some optimization opportunities, and all the other nodes that might help you to get started. Besides that, with the help of the great Espressif engineers, we have created some ready-to-use projects in LVGL's GitHub organization for some ESP and M5 stack development boards. You can just go to those projects in github.com/LVGL. You can clone them and find all the related get started informations in the README. They are optimized for performance, and the target was the simplicity. So these can be considered as a good getting started projects that you can just easily extend later on. And finally, the engineers of Espressif maintains and creates the ESP BSP repository as well, where you can find several LVGL related demos. Okay, now we have arrived to the most important and most interesting part of the presentation. We will see some LVGL features and check them out to see how you can make your UI better on ESP32 P4. But let me tell you a few words about P4 first. As you probably know, it's a dual-core 400 megahertz chip, which is really amazing because 400 megahertz is already enough even for really complex and good-looking UI effects as well. It also has 768 kilobytes of on-chip SRAM, which can be enough for a double buffered 480 by 272 resolution display. So you don't have to place the frame buffers into the slower PSRAM, but for mid-size displays, you can use a faster internal SRAM. According to our experience and measurements, the maximum reasonable resolution for ESP32S3 was 800 by 480. It was sometimes a little bit lucky, but with careful design, you can create decent UIs on this resolution. However, for P4, even way larger, like HD screens, were working very well. So I think it's a huge step forward. So the first set of features that I like to show you is transformations and masks. You have already seen the transformations on our website, how they work and what you can do with those. But in this video, you will see them in the action and also the masks. But let's see the video and I will tell more about these after that. So these labels on the left-hand side are normal label widgets. These are not just images, meaning they are dynamic. You can change them at any time. And what we have done is made LVGL to transform them a little bit and also scale them as the arc approaches them. Regarding the mask, these numbers here are maxed a little bit. If you take a closer look, you can see that the upper and the lower part of these numbers are faded a little bit. To do so, we have created an image, which is just an 8-bit image. The middle is white and the ends are getting blacker. And in LVGL version 9, the later version, you can add this mask to any widget and it will be just mask out the black parts accordingly. Here we have created an image for the mask, but it could be generated in runtime as well. In the latest versions, you can render anything that LVGL can render in L8, so lightness 8-bit format as well, which can be used for a mask later. So in summary, you can transform any widgets as an image, not only images. You can generate masks at runtime. These masks can be labels or gradients or any shapes, and you can apply them on any widgets. I mean the masks. Oops. The other two features that I like to show are the Lottie animations and the multi-language support. If you are still new to the Lottie animations, these are like SVG images, but animated. They can be considered as a better version of the GIF animations because GIF was not really scalable because it was like pixel-based, not vector, and GIF had only 256 colors, while Lottie has ARGB 8888 colors, so it utilizes the whole RGB spectrum with 8 bits per channel, and also vector-based, so you can render the Lottie animations any size. Okay, let's see it in action. You will see it here. So yeah, this nice cogwheel animation is stored as a Lottie description and being rendered on the canvas. This canvas is basically just a buffer that can be provided externally by the user to the Lottie widget, meaning you can control where this buffer is located. It can be placed in internal RAM, PS RAM, or any other places that you like to control the memory usage in a bit more conscious way. Okay, here I have just selected the Chinese language, so the whole UI is translated to Chinese now. It can be possible, it can happen in an easy, simple way because LVGL supports the whole UTF-8 encoding, and you can type any UTF-8 encoded string and LVGL will be able to process it. We also have an internationalization or multi-language support tool, which can extract the strings to translate from the source code, place them in YAM files. In those YAM files, you can add the related translations and compile a C file from those translations. And of course, that C file can be added to your project, and LVGL can get the translations from that C file. It supports all the fallbacks. So for example, if there is no Chinese translation for a word, it will use the English version. If there is no English version either, it will use a tag, which was used in the code. One more interesting thing is if you have a Chinese UI, you might have like thousands of symbols or characters on your UI, and it's not really reasonable to convert a Chinese font with 3 or 5 different sizes and thousands of characters because it would consume like megabytes of flash. Instead, you can use LVGL's built-in TTF render libraries to open a TTF file and render only the required characters. It can also cache the characters for you, so the performance will be great as well. Actually, it's quite similar with the Lottie animation. It uses a built-in but third-party library in LVGL. In order to use Lottie animations, you just need to enable the Lottie support in menu config, and LVGL will compile everything automatically for you. There is one more translation that I like to show. This is the Arabic translation. As you can see here, not only the text are right to left written, but in Arabic languages, all the UIs are arranged from right to left. For example, the sliders are growing from right to left. The off state of the switches are on the right. And basically, everything is just flowing from right to left. And this is working in LVGL automatically. For example, this line was created by a flex layout, placing these items next to each other. However, when it detects that now we are in a right to left context, it will swap the directions automatically. The sliders and the switches can also detect the right to left or left to right context and change their behavior rendering accordingly. Okay, here I have listed some other features which are added in the latest version of LVGL, version 9. The first one is parallel rendering. This LVGL version 9 can utilize multiple CPU cores during rendering. Of course, the possible performance boost that you can achieve depends on the arrangement of the UI, how many things can be rendered in parallel. But according to our measurements, we can see that if you utilize both cores for rendering, you can experience like 30% boost. We have also added assembly accelerations to the rendering, so the most performance critical parts are written in assembly to make sure that you can make the most out of the given architecture. You can just enable these in LVGL's configuration file, and they will be added automatically. We also have a platform-independent profiler. In the practice, it means that we have already added some special tags to the performance critical functions, and when the execution reaches those tags, they will add a string with a timestamp to a buffer, and when those functions exits, another tag or other string will be added to a buffer. So a lot of strings like this will be buffered, and when the buffer is full, it will be flashed via a serial port or something like that. And in the end, you will have a profiler log with a lot of function entries, function exits, and related timestamps. It's a little bit hard to digest in this form. However, there's a website which visualizes all this for you. You can see in which functions were executed, and you can see the whole stack actually. Like this function was running for 1 millisecond, another function was called from there at this time, and it was running for 200 microseconds, and so on. It already helped a lot to us to debug performance issues and even very complicated scenarios. And yeah, it's a platform-independent profiler, meaning that you can use it on any platform, but in your application code as well. You can just use a few macros to add those tags into your functions, and you can monitor the performance. And finally, I'd like to tell you a few words about the observers. They can help us to realize data binding. In the practice, it means that you can create so-called subjects. These subjects are just storing values like an integer value, a pointer, or a string, or something like that. And various parts of the UI in the application can subscribe to these subjects. For example, you can create a subject for the user count, and a label in your UI can subscribe to the user count subject. This way, when the user count changes, the label will be notified and it can update its text accordingly. There are some built-in functions to make this process smooth and simple. But the great thing is that all these are dynamic. So if you create a label, you can just subscribe to the subject. It will read the current value and set the initial text accordingly. If you just delete the label, it will unsubscribe automatically. So it supports very well the dynamic widget creation and deletion. In the practice, it really helps a lot with dynamic UIs and to keep things simple, because these subjects can be considered as a single source of truth. You can just set the values there, and everything can read the current value from there. They can be also considered as the API of your UI. For example, this user count subject that I have just mentioned can be the value in it can be set by the application. So you don't have to create like large API functions to set the user count. You just need to document what subjects you have, and the application can set or read the current value from there. And the UI and the other parts of the application will be notified accordingly. Okay, that's it about P4 and LVGL version 9. Let me tell you a few words about our future plans, because quite exciting things are happening right now. In July, we have started to work on LVGL's official UI editor. It will be a developer-centric, declarative UI editor. By developer-centric, I mean that our goal is not to create a designer tool where anyone can put together fancy UIs, but instead we would like to help the developers to re-implement the UIs which were created by a designer. Of course, we will create a lot of ready-to-use components and demos that can be reused by people, but the main goal is to help the process of re-implementing the designs. We have found that in most of the projects that we were working on and we have seen, the designers are using Figma. So our goal is to make it as simple as possible to re-implement the Figma designs in our UI editor. If you would like to design a UI, we recommend using Figma. Design the UI there, because it's a very professional tool developed by many experts and used by large companies. We won't be able to create a better designer tool, but we can create a tool for you which helps you to implement and maintain your UI. Actually, this editor will consist of 3 parts. First, the editor itself, where you can create the UI in a declarative way. It means that you can describe the hierarchy of your UI like an HTML file in XML, and there will be a preview which shows you how it looks like. You can manipulate the widgets, all the properties, and finally export C files. As it's a developer-centric tool, it's a very high priority for us to make the generated code easy to use and easy to extend. It's not okay to have a large, bulky generated code that you cannot really touch. It can be very modular and integrated smoothly with the code that you add as a developer. As I mentioned, the second part should be a Figma importer, which helps you to move the Figma design to the editor. And finally, the third part that I haven't mentioned yet is an online preview. So once you have created some components in your editor, you will be able to push these or compile these to a website, just like we have compiled our demos to HTML files and show them on our website. You will be able to compile your components, every single component, into a small web page, and we will display them in an organized way where the designers or the other parts of your team can preview them online without installing any SDK or developer-related tools. Once we will have all the components and all the UI assets there, we can also run a tester. We can just compare how your components look like, and if there is some difference, we can detect some regressions and notify you that, hey, some components are not okay, you should take a look and fix them. So yeah, that's our plan about LVGL UI editor. We are planning to release it in next year, summer, but until that we will publish some beta versions so that you can test it and give us feedback. We would be very happy to hear how you like it and hear any improvement proposals. But yeah, besides the UI editor, we are working on a project creator as well. It's a related tool. It's like we will release it before the editor to have like a hub where all the development boards that we maintain in LVGL's GitHub organization can be created as a ready-to-use project. You can just launch this tool as a VS Code extension, Eclipse plugin, or a standalone application. You can select the vendor, select the development boards, also change some configurations, click a button, and the project will be created for you. It's very helpful for us because this way we can verify that the basics of our editor are working well. Like it's really running as a VS Code extension, Eclipse, standalone application, and hopefully on web as well. And it will also help you to create LVGL projects easily with some tweaking on the configuration. Later, we will extend this project creator to create editor projects, of course. So it will be like, if you would like to create a new project, launch the project creator, select the board, and after that, launch the editor and export the UI into the board that you have created. So that's it. We are working on the UI editor and the project creator right now. And yeah, we will share some news about these later. And thank you for watching. I would be happy to hear your questions.